In the waning days of World War II, the Japanese battleship Yamato embarked on a mission that would become a defining moment in naval warfare. At over 70,000 tons, she was the most massive warship ever constructed. A steel titan developed in absolute secrecy and armed with guns of unprecedented size. The ship's final journey began in December 1941, part of Operation 10 Ichigo, Operation Heaven 1. Her destination was Okinawa, a critical strategic point in the Pacific. If the Americans captured these islands, they would have a launching pad for a full-scale invasion of Japan itself, threatening to bomb Japanese cities relentlessly. Aboard the Yamato were more than 3,000 sailors, each crucial to operating this maritime colossus. The plan was audacious and desperate: beach the battleship at the landing site and unleash a devastating barrage of gunfire. Simultaneously, Japanese aircraft would conduct kamikaze attacks, hoping to inflict maximum damage on the American fleet. Senior officers knew the mission was likely suicide. The odds were overwhelming, the strategy born of desperation, yet a sense of duty propelled them forward, willing to sacrifice everything to protect their homeland. This wasn't just a naval battle. It was to be one of the most significant and tragic engagements of modern naval warfare, a testament to the extraordinary lengths nations will go to in times of existential conflict. The Yamato herself was more than a ship. She was a symbol of Japanese engineering prowess and military ambition, a vessel that had struck fear into the hearts of her enemies when first launched. Her story would become legendary, a complex narrative of technological achievement, national pride, and ultimate sacrifice. World War I had ended, and while America and Britain erupted in jubilation, Japan quietly continued its daily life. The war's conclusion marked a pivotal moment for the land of the rising sun, which had proven itself a significant global political player. During the conflict, Japan had assisted Britain against German naval forces in the Pacific. However, this alliance was far from altruistic. Japan's true intention was territorial expansion, with ambitions to spread its influence across the Pacific and reduce neighboring China to a mere protectorate state. The Japanese government understood that achieving its goals would require military force, particularly a confrontation with the US Navy's Pacific Fleet. To prepare, they began constructing a powerful naval force, initially planning 8 new battlecruisers and 8 battleships. This ambitious plan was abruptly interrupted by the 1922 Washington Naval Treaty. The agreement sought to limit naval fleet sizes, and Japan, one of 5 signatories, was restricted to maintaining naval strength no more than 60% of Britain or America's. This humiliating constraint sparked internal resentment within the Japanese Navy. By the late 1920s and early 1930s, naval planners had conducted extensive research. Growing support for treaty withdrawal coincided with designs for a series of super battleships. Recognizing they could not match American and British production in a prolonged conflict, Japanese strategists developed the Kentai-Kessen doctrine. This strategy centered on a single decisive naval battle. While the US and Britain possessed more ships, Japan would counter with superior vessels, battleships designed to be fast, heavily armored, and capable of engaging multiple enemies simultaneously. The stage was set for a confrontation that would reshape the Pacific's geopolitical landscape. The Japanese naval designers of the 1930s had an extraordinary challenge ahead of them. After withdrawing from international treaties and facing internal political shifts, they were granted unprecedented freedom to create a battleship that would dominate the Pacific. Their guiding principles were clear: build a vessel faster and more powerful than any American battleship. They assumed US ships would not exceed 25 knots or have guns larger than 16 inches. Their own design would need to reach 27 to 30 knots and carry massive 18-inch guns, the largest ever mounted on a ship, a record that still stands today. The initial design, A140, was truly massive. At 294 meters long and 69,500 tons, with turbines producing 200,000 horsepower. It would have rivaled the largest passenger liners of the era. Naval planners quickly realized this was impractical and began refining the concept. Between 1934 and 1937, the design underwent 24 revisions. Tonnage and length fluctuated until a final configuration was agreed upon. Construction was approved, and a keel was laid at Kure Naval Arsenal in Hiroshima, a ship stretching over 800 feet. The hull's design was revolutionary, yet followed fundamental naval engineering principles. A steel plate keel formed the ship's backbone, running almost its entire length. Frames created the structural ribs, giving the vessel a unique shape. When viewed at the waterline, the hull resembled an elongated teardrop, a narrow, sweeping bow that sharply tapered at the front, with a relatively compact stern. This distinctive shape wasn't merely aesthetic. Extensive testing showed it would help the Yamato achieve its critical speed advantage, enabling it to outpace potential American adversaries. The Yamato's design was a marvel of naval engineering, with its extraordinary speed made possible through innovative hydrodynamic principles. Japanese naval architects understood that a ship's hull shape was crucial to achieving high velocities across the ocean. The vessel's remarkable length was not merely about creating a massive platform for guns. Instead, it served a critical hydrodynamic purpose. By extending the hull, designers could optimize wave interactions to reduce resistance. Professor Jerry Milgram explained this phenomenon simply. Longer boats generate longer waves at high speeds, and longer waves move faster than shorter ones. At specific speeds, the ship could minimize drag by perfectly aligning wavelengths along its hull. When bow and stern waves meet, they create significant wash and resistance. A longer hull keeps these wave formations further apart, allowing the ship to maintain speed more efficiently. Another groundbreaking feature was the bulbous bow, the largest of its time. Originally discovered during warship ram installations in the 1800s, this design created a wave ahead of the ship's bow that, at optimal operating speed, would cancel out resistance waves. The result was dramatically reduced drag and improved fuel efficiency across all ship classes. The Yamato's hull was a teardrop shape engineered for cutting through rough seas. Like a chisel slicing into waves, its long, thin bow was designed to maintain speed in challenging weather conditions. However, this design came with a trade-off. The narrow bow reduced buoyancy, potentially allowing waves to wash over the forecastle in turbulent conditions. Moving 70,000 tons of steel at over 25 knots was an extraordinary engineering achievement, made possible by these sophisticated design principles. To tackle the challenge of propulsion for Yamato, Japanese naval engineers faced a complex design problem. Their goal was to create a battleship that balanced power, speed, range, and fuel efficiency. Early considerations included steam turbines, which had driven ocean liners to record speeds since 1907. However, these engines consumed massive amounts of fuel oil. By 1935, Japanese engineers had developed powerful double-acting diesel engines capable of generating 10,000 horsepower. They initially planned a hybrid propulsion system, 2 diesel units and 2 steam turbines, each driving a separate propeller. This configuration would theoretically provide over 9,000 nautical miles of range at cruising speed. But Yamato was not designed to be a sleek ocean liner. Her primary purpose was to engage in brutal naval combat against formidable opponents like American warships with their devastating 16-inch guns. A single penetrating shell could potentially sink the ship in seconds. The vessel's hull design was revolutionary, more reminiscent of a modern ocean liner than traditional battleships. Japanese designers meticulously tested and refined the shape using over 50 models in a Tokyo tank. The bow was ingeniously engineered to flare upward and outward above the waterline, providing critical buoyancy and keeping the ship's head above waves. This innovative design had significant performance benefits. The smooth hull shape meant Yamato's engines would require 15,800 fewer shaft horsepower to achieve her desired 27-knot speed. The dramatic bow flare also served a practical purpose, keeping the massive anchors well clear of the bulbous bow below. The hull's design was a testament to the advanced thinking of Japanese naval architects, creating a structure that was remarkably modern, even by contemporary standards. Every aspect of Yamato's construction was carefully considered to maximize her effectiveness as a powerful naval weapon. The Yamato's armor was an engineering marvel, designed to protect the battleship's most critical spaces both above and below the waterline. While armored citadels were standard on battleships, the unprecedented thickness of Yamato's protection set it apart. Spanning approximately 600 feet from the aftermost to the forward gun turret, the armored box extended 2 to 3 stories below the waterline. The design philosophy prioritized shell deflection through strategic angling. By creating sloped surfaces, engineers increased the likelihood of enemy shells being deflected and forced shells to pass through more steel if they did penetrate. Critical to the ship's survival were the powder magazine protections. A single hit to these areas, where tons of cordite explosives were stored, would spell certain doom. To prevent this, the armored bathtub featured extraordinary steel thickness, 410 millimeters, 16 inches on the sides, hardened through a decade of research. The top of the armored box, while slightly thinner at 200 to 230 millimeters, about 9 inches, offered remarkable protection. It could withstand hits from over 30 kilometers away, and would require a precisely dropped 1,000 kilogram bomb from nearly 3 kilometers altitude to breach it. An additional 9 millimeters layer beneath the main armor provided extra protection against potential splinter damage. Forward and rear ends of the citadel featured sloping faces up to 340 millimeters, 13.3 inches, thick. Outside this armored core, torpedo protection bulges were installed, vacant spaces designed to detonate torpedoes before they could reach the main armor. These bulges were divided into watertight sections, providing additional buoyancy to the massive hull. The Japanese Navy's gunnery trials had revealed that underwater shell trajectories could pose significant risks. The enormous torpedo bulges served as a critical defensive mechanism against such threats, demonstrating the meticulous engineering that went into the Yamato's design. Yamato's design went far beyond typical naval engineering of its time. Her armor wasn't just an added layer, but a critical structural component, a concept first developed with the heavy cruiser Furutaka. Electric welding instead of riveting made her simultaneously incredibly strong and surprisingly lightweight for her massive size. The ship's armor itself was a marvel, weighing around 22,900 tons and comprising 30% of her total displacement, equivalent to nearly 2 entire Liberty ships. This made her the world's most well-protected battleship, though not without complexity. The armored engine room box created a significant challenge. Diesel engines couldn't be replaced, forcing the designers to rely solely on turbines. This compromise reduced her operational range from 9,000 to 7,200 nautical miles. Yet her power remained remarkable. 4 turbine engines generating over 150,000 shaft horsepower could propel her at extraordinary speeds. 12 massive Campon boilers, strategically compartmentalized to minimize potential damage, could generate steam at 325 degrees Celsius. During her November 1941 sea trials between Kyushu and Shikoku, Yamato demonstrated her potential, racing over 27 knots. However, such speed came at a steep fuel cost, 63,000 kilograms per hour with all boilers firing. Her standard cruising speed of 18 knots was more sustainable, leveraging her hull's efficient design to reduce engine strain and fuel consumption. Battle survivability was meticulously considered. Her hull contained 1,147 watertight compartments, with all but 82 located below the heavily armoured midsection, ensuring remarkable resilience against potential damage. The Yamato was an extraordinary battleship designed with survival in mind. Her compartmentalized hull and strategic layout meant she could absorb significant damage while remaining afloat. Even if her bow or stern sections were hit, the ship possessed remarkable reserve buoyancy. Her forward freeboard could drop from 10 meters to just 4.5 meters, and she would still ride the waves. Stability was another crucial engineering consideration. The ship could roll up to 20 degrees without compromising her seaworthiness, a testament to her sophisticated design. Her vulnerability points were meticulously protected. The funnel uptakes, which could potentially become a critical weakness, were ingeniously armoured. Bomb protection was particularly sophisticated. The funnel's uptakes passed through a 380mm thick armoured grating with carefully placed holes for smoke passage. The funnel itself was angled sharply backwards and plated with 50mm of armour, making direct hits challenging. If a bomb somehow navigated down the funnel, it would encounter 15 inches of hardened molybdenum alloy armour. Critical machinery spaces were enclosed in miniature armoured boxes beneath the waterline. These spaces, including main and auxiliary rudder machinery rooms, were shielded by steel plating between 200 and 360mm thick. Even under intense shelling, Yamato could potentially steer herself to safety. More than a mere ship, Yamato was a floating fortress, unprecedented in naval engineering. Her designers understood that defensive capabilities were only half the equation. The ship needed to strike back with overwhelming force, guided by the decisive battle doctrine that demanded superior firepower at sea. The gun chosen for this mission was so revolutionary that its true specifications remained top secret. The massive guns of the Yamato were a technological marvel, far more powerful than their official designation suggested. What was publicly called a 41cm or 16-inch gun was actually a staggering 46cm or 18.1-inch weapon, stretching nearly 70 feet long. These guns were arranged in enormous rotating turrets that could aim forward or to either side. The sheer scale of these weapons was mind-boggling. The Type 94 460mm gun required 6 cordite explosive charge bags, each weighing 55 kilograms. To fire a single shell demanded 330 kilograms of charge, with the shell itself weighing a hefty 1,460 kilograms, comparable to a family car. Each turret could unleash 3 shells every 27 seconds, meaning the Yamato could hurl nearly 26,000 kilograms of metal downrange every minute. These incredible guns could reach targets over 40 kilometers away, powered by 6 cordite charge bags. The turrets housing them were engineering marvels in their own right, each weighing over 2,700 tons, equivalent to an entire destroyer. The ship carried 3 such turrets fitted into massive circular spaces on the weather deck. Powered by twin 500 horsepower hydraulic engines, these turrets could rotate at about 2 degrees per second. Their immense weight came primarily from armor, a critical feature given their exposed position. The turret roofs were 270mm thick, sides at least 250mm thick, but the facing armor was an incredible 650mm, the heaviest on the entire ship. The gun's barbette extended deep into the armored citadel, housing cordite charges, shells, and the hundreds of crew members needed to operate these massive weapons. The barbettes themselves required up to 560mm of armor to protect against direct hits. The Yamato's shells were equally sophisticated. The primary type was the Type 91 armor-piercing projectile, weighing 1,460 kilograms. It featured a specially designed wind and water-resistant hood cap to protect the shell during flight, with an optimized shape that performed effectively both in air and water. Yamato's massive 46cm guns were more than just massive weapons. They were engineering marvels designed to deliver devastating blows against enemy targets. These guns fired multiple types of shells, each with a unique purpose and deadly effectiveness. The primary armor-piercing shells were incredibly potent, made of steel and packed with 34 kilograms of trinitro-anisole explosive. They could punch through nearly half a meter of armor from over 20 kilometers away. These shells traveled at a blistering 780 meters per second, outpacing an AK-47 bullet. Another remarkable shell was the high-explosive variant, surprisingly light for its caliber. Despite British warships of the First World War using larger explosive charges in smaller guns, Yamato's shell was designed specifically for soft targets, reflecting the ship's strategic intent to engage the American Pacific Fleet. The most innovative shell was the Type 3 Sanshiki anti-aircraft shell, a uniquely Japanese weapon. Functioning like a massive shotgun, this shell would detonate at a predetermined height, unleashing 996 incendiary tubes that created a 5-foot cone of flame burning at 3,000 degrees Celsius. The Japanese Navy was so concerned about American air power that nearly half of Yamato's ammunition consisted of these anti-aircraft shells. While the guns were impressive, their accuracy was a work in progress. At maximum range, they could achieve spread patterns of 400 to 500 meters, which was relatively tight for such extreme distances. The designers had contemplated even longer 50 caliber guns but ultimately rejected them due to the prohibitive weight and cost. The Yamato's fire control system was a marvel of Japanese naval engineering, relying not on radar but on advanced optics and sophisticated computer technology. At the heart of this system was a complex network of rangefinders and computers that enabled precise targeting without American-style radar guidance. High above the bridge, a massive 15-meter rangefinder stood as the primary targeting device, with 3 additional rangefinders located in the gun turrets. This intricate system used a pair of reflectors, one fixed and one movable, to calculate target distance through trigonometric calculations. The rangefinder data was fed into the Type 98 Shagakiban computer, operated by a 7-man crew in the Fire Control Center. A companion system, the Type 98 Soku Tekiban, simultaneously tracked target speed and heading. These computers communicated with the Type 98 Hoiban gun directors, which calculated the precise firing solutions needed by gun crews. Mounted in lightly armored pillboxes near the rangefinders, the Hoiban units were critical. They electromechanically transmitted targeting data to the gun turrets, where operators used a follow-the-pointer method to align gun elevation and positioning. An ingenious interrupter system in the Soku Tekiban computer staggered gunfiring to prevent shell interference. The immense power of the 46-centimeter guns was so tremendous that the bow forward of the first turret remained deliberately stripped of structures. Otherwise, the muzzle pressure would simply obliterate everything in its path. This unique design allowed the turrets to fire independently, using their own rangefinders and periscopes to engage targets without direct bridge guidance. The result was a fire control system of extraordinary complexity and precision, reflecting Japan's technological approach to naval warfare during World War II. Yamato was equipped with Japan's latest radar technology, the Type 21 Go Dentan-kai, which had notable limitations in its detection capabilities. While the radar could identify air targets up to 100 to 20 kilometers away, sea targets could only be detected within about 30 kilometers. The radar arrays were installed beneath the arms of the 15-meter rangefinder atop the ship's mast. The battleship boasted an impressive array of secondary and anti-aircraft armaments. Most notably, Yamato carried the main guns from the light cruiser Mogami, massive 15.5 centimeter guns capable of launching shells over 25 kilometers. These guns were so substantial that each turret weighed nearly 200 tons, and the ship carried 4 of them. Complementing these massive guns were 12 12.7 centimeter Type 89 5-inch guns mounted in twin turrets. These guns were remarkable for their rapid firing rate of 8 to 14 rounds per minute and could be directed to engage enemy aircraft. As the threat of air attacks increased, Yamato's anti-aircraft capabilities grew dramatically. By the war's end, the ship bristled with over 150 guns, a significant increase from its original 24. Another unique feature was the vast aircraft hangar in the stern, which could accommodate 7 float planes, specifically the Mitsubishi F1M2 and Aichi E-13A1. These aircraft were primarily used for reconnaissance but could also carry small bomb loads. An enormous 6-ton crane, stretching 20 meters long, would retrieve these planes from the water. A sophisticated rail system then allowed the crew to smoothly transport the aircraft back into the hangar's protective interior. Throughout her career, the radar system was upgraded, though radar-directed gunfire remained a primitive concept in the Japanese Navy. The ship's fire control system remained primarily optics-focused, with target acquisition happening from miles away. Yamato was more than just a warship. Her vast hull provided unprecedented comfort for her crew of over 2,000 men, offering spacious living quarters that far exceeded those of other vessels of her time. An advanced air conditioning system even cooled select living areas, providing relief from the brutal Pacific heat where temperatures could easily surpass 100 degrees Fahrenheit. The ship's design was meticulously planned for both functionality and efficiency. Where other warships traditionally mounted lifeboats on deck, sacrificing valuable anti-aircraft gun positions, Yamato's designers created 4 massive hangars specifically for her 14 boats. Many of these boats had their own engines and could be safely stored inside the hull, protected from potential damage. A versatile crane system could both handle aircraft and transport these boats, ensuring they remained undamaged even during massive turret firings. At her core, the bridge represented Yamato's critical command center. Encased in an armored box with walls up to 500 millimeters thick, it was directly linked to the ship's main citadel, deep within the hull. Here, Captain Kosaku Aruga would survey the ship's trajectory, knowing full well that this mission would be her last. In April 1945, Yamato, the pride of the Japanese Navy and arguably the most formidable battleship ever constructed, was dispatched to Okinawa. Though originally designed for decisive naval battles against enemy battleships, she would now attempt to disrupt American invasion landings. Built over a decade earlier with a specific combat doctrine in mind, Yamato was about to face a very different war than the one she was designed for. Japan had been locked in a war, could never win. With its prize battleship Yamato repeatedly confined to harbors, earning her the mocking nickname Hotel Yamato among other crews. Her hoped-for decisive strike never materialized, and modern American battleships with radar-guided guns had replaced the antiquated vessels she was meant to destroy. Her final mission was a desperate one-way journey designed for martyrdom. Accompanied by 9 other warships and bolstered with enhanced anti-aircraft defenses, Yamato faced an overwhelming force of 15 US carriers that would seal her fate. Swarms of American aircraft hunted her mercilessly, striking repeatedly with devastating precision. Hit by around 10 torpedoes and over 15 bombs, the ship began to list dangerously. Her designed stability of 20 degrees was tested to its limits as flooding quickly overwhelmed her. In a desperate attempt to prevent capsizing, her engine rooms were immediately flooded, a move that instantly killed hundreds of men working below decks. More, torpedoes struck her port side, and with her rudder jammed, Yamato became a ruined, scorched hulk, limping through the water. Captain Aruga remained resolute, tying himself to the ship's compass binnacle as she went down. Just 2.5 hours after the first enemy aircraft appeared, Yamato rolled over with a thunderous roar. The truly catastrophic moment came when her powder magazines erupted. Hundreds of men were in the water around the blazing ship when an explosion, one of the world's largest non-nuclear blasts, tore her hull apart. In mere seconds, the monument to naval engineering became nothing more than scattered scrap metal, with nearly 3,000 lives lost. Her final, futile contribution was shooting down just 10 US aircraft at the cost of a dozen Japanese lives. Yamato represented the pinnacle of a dying breed of warship, a testament to an era of naval warfare rapidly becoming obsolete. During World War II, battleships reigned supreme until swarms of tiny aircraft proved they could sink these massive steel platforms with shocking ease. The lesson came at a tremendous cost, repeated across multiple famous naval battles. Ships like Repulse, Prince of Wales, Bismarck, Arizona, Yamato, and Musashi all demonstrated the brutal vulnerability of even the most heavily armoured vessels. The impact was so profound that post-war battleship plans were abandoned entirely. HMS Vanguard, the final battleship ever constructed, served just 14 years before being scrapped, a testament to how quickly naval warfare had transformed. Yamato embodied this tragic evolution. A decade of meticulous design and construction resulted in a ship that was obsolete the moment she entered the water. The Japanese government recognized this harsh reality, ordering all documentation about her to be destroyed. So complete was this effort that the first non-US photograph of the ship didn't emerge until 1948, 3 years after the war's end. Today, fragmentary records and photos provide glimpses into Yamato's remarkable story. She represented an extraordinary engineering achievement, a magnificent war machine tragically designed for a conflict that had already passed her by, an incredible vessel ultimately rendered irrelevant by the rapid technological advances of aerial warfare.